Hello everybody, welcome back to Maths Made Easy. My name is Thaddeus, and today we're doing differentiation. So let's get on with it. What is differentiation? So basically, you have to first know what a gradient is. And I'm assuming you know what a gradient is. If you have a straight line, for example, gradient is just how steep it is, and you calculate it by doing the change in y, which is how high up it goes, which is called delta y, over delta x, the change in x, which means how much horizontally it grows. And if it goes like this, that means the gradient is going to be higher. If it goes like this, the gradient is probably going to be lower. And if it goes like this, the gradient is negative. And yeah. But when you have a curved graph, for example, a parabola, the gradient changes. So if you imagine like biking down here, it's going to be steeper here, kind of flat here, and it's going to be uphill here, which means negative here, then 0 here, and then positive here. And it changes depending on where you are. But you can find out the gradient at a specific point by either drawing a tangent, which is something we won't cover here, or differentiating it, which means if you know the equation of the graph, you can do something to it. You differentiate it to give it to you another equation, which means at any x coordinate, if you put in the x coordinate into this differentiated equation, you'll get the gradient. So how do you differentiate? So let's say you have a equation of a graph, x squared plus 3x minus 5, right? And if you're doing IGCSE or GCSE, you will only be asked to differentiate terms like this, where it's like x to the power 5 or 3x. You won't really be asked to do like exponential graphs or hyperbolas. It's only whole number powers of whole number powers of x, positive whole number powers of x, and obviously just constants without the x. But yeah, anyways, if you want to differentiate this, what you would do is you would go by each term, right, and apply the power rule. So each term is each thing here that's being added. So we have one term which is x squared, another term which is 3x, and another term which is minus 5. And each term, what you want to do is you want to see the power that x is raised to, which in this case it's 2, and you want to be multiplying it by the number in front, and then subtract 1 from the power. So I'll start with x squared. What you would do is you remember that there's a 1 in front of the x, so it's actually 1x squared. And you would do 2 times 1, so it would be 2. And then you would subtract 1 from the 2 to get 2x to the power 1. Remember, anything to the power 1 is just itself, so that's just the same thing as 2x. So x squared turns into 2x. Then for the 3x, remember that's 3x to the power of 1, right? Then do 1 times 3, which is 3, and then subtract 1 from the 1, so x to the power of 0. And anything to the power of 0 is 1, so it would just be 3 times 1, which is 3. So then the whole thing with these two terms squared together and would be 2x plus 3. And then for the minus 5, we just ignore it. We don't need it, basically, because it would always be minus 5 and then x to the power of 0 if we want to, because anything to the power of 0 is itself. And then you would just do 0 times minus 5. And you would immediately get 0, and then no matter what you multiply it by, I don't know why that line came, but no matter what you multiply it by, it won't affect it because it'd just be 0, right? So this is the symbol for the differentiated equation or differential equation. Derivative, I think also, yeah. It's dy over dx. You can think of it as like change in y over change in x, but yeah. And you get 2x plus 3. So if we draw the graph of x squared plus 3x minus 5, I'll just sketch it. Maybe something like this, right? It's a very bad sketch, but basically, if you give the x coordinate a specific, so if you want to find the gradient of the graph at x equals 0, we would put 2 and 0 plus 3, which is just 3, which means here the gradient of the graph is roughly 3. And if we want to find out negative 4, for example, the gradient of the graph is roughly 8 here. I mean, my bad. Roughly negative 5. I made a mistake there, but yeah, roughly negative 5 here. So you can see how you can figure it out, and it'll be 100% accurate, unlike a tangent. If you're drawing a tangent line where you can have some human error with the drawing, but yeah. So differentiate these slightly harder equations with a bit higher powers, but apply the power rule just the same. It'll work. Okay. So for the first one, dy over dx. So you do 3 times 8, which is 24. X, and then minus 1, which would be 24x squared. And then x, just on its own, is 1x to the power of 1. 1 times 1 is 1, and then x to the power of 0. X to the power of 0 is just 1. So it'll be 1 times 1, which is 1. And then you might have noticed that basically if it doesn't have an x, it's not going to be a part of it. So yeah. So that would be the derivative of 8x cubed plus x minus 4. Now you can try this one. Or, you've already tried this one. What am I saying? Dy over dx, 7 times the 1, 7. And then minus 1 is 7x to the power of 6. And then 6 times the 3 is 18. Or 6 times the minus 3. Make sure you're mindful of the minuses. So minus 18. And then x to the power of 5. Yeah. Next thing you might have to know for the exam is turning points, or stationary points as they're called sometimes, is that if you have a curved graph, some curved graph have a point, like in the parabola it's called the vertex, but where the gradient is 0 and it kind of turns. That's what's called a turning point. And for a cubic graph, it might have 2, it might have 1, or it might have 0. That one I think has 2, but yeah, you might have 1, 2, or 0. 1, 2, or 0 turning points, and then greater powers to the power of 4 to the power of 5, they might have even more turning points. But how do you find the turning points? Well, the first thing you want to do is find the derivative. So I'll just use the equation we used before, x squared plus 3x minus 5. And derivative, y equals, derivative would be 2x plus 3. And remember, what this shows you is the gradient at any point. But we want to find a point where the gradient is 0. So what we want to do is set that to equal 0. And then solve for x. So we can find the x coordinate of the stationary point. So you have 2x equals minus 3. And then x equals minus 1.5. Divide both sides by 2, right? If x equals minus 1.5, then we can find y by putting it back into the original equation, not the derivative. You put it back into the original equation. So y would be minus 1.5 squared plus 3 times minus 1.5 minus 5, and I'll just plug that into my calculator. So we have y is minus 7.25. So then the coordinates of the turning point is going to be the x coordinate, minus 1.5, and the y coordinate is minus 7.25. And if you want, you can do like a little sketch just to make sure. Minus 1.5, minus 7.25, that makes sense. If you don't know how to sketch, then it's fine, but this would be the turning point. And for cubic graphs, the derivative would be a quadratic. If you haven't noticed, the whole thing kind of goes down a level if you derive it. So the quadratic becomes linear, the cubic becomes quadratic. And since the cubic is quadratic, and if you have a quadratic to the power that equals 0 and you're trying to solve for x, you can have either 1, 2, or you will have 2 solutions, sometimes 1, right? And sometimes you'll have none, so that's why they might have 2, 1, or 0 turning points. So yeah. try finding the turning point of this. Okay, so step 1, find the derivative. Power rule, 2 times 7, 14, minus 1 is 1, which is just x, and then plus 7, because 1 times 7 is 7, and then x to the power 0, and then you take this one out. Then we set that to equal 0, then 14x equals minus 7, and x equals minus 0.5 by dividing both sides by 14. And then we plug that back into the original equation, which you might not be able to see, but 7x squared plus 7x minus 4, which means 7 times negative 0.5 squared plus 7 times negative 0.5 minus 4, and then I'll solve it. So the answer is minus 5.75 for y, and then the coordinates would be minus 0.5 minus 5.75. Okay, now you can pause and try to find the turning point of this equation. Okay, first find the derivative, which would be 3x squared, 3 times 1 minus 1, plus 2x, 2 times 1 minus 1, and then plus minus 8, my bad. 1, and then, yeah, you know. Then you set this derivative equation to equal 0, and then you try to solve for x, just like how you would solve a quadratic. Here I'll do factorization. So first multiply the a term by the c term, get minus 24, which is equal to minus 6 times, plus 6 times minus 4, and 2 is equal to 6 plus minus 4. So we would use 6 and minus 4 as the two things we split the b term into. You get 3x squared minus 6, plus 6 minus 4, x plus 6x minus 8, and you factorize. I'll just skip ahead. Okay, now what I've gotten is x equals 4 over 3 or x equals minus 2. Sorry for my handwriting being really messy, but yeah. Now we can plug this back into the original equation to get the y value. I'll go over here to do this. The original equation was x cubed plus x squared minus 8x. So first with 4 over 3, I'll just put this calculator and tell you. Okay, we got roughly minus 6.518, which, minus 6.52, basically. That's y, and then so our first coordinate point, our first turning point is 4 over 3 minus 6.52. They might not ask you these really hard numbers or unclean numbers, I guess. I just didn't have enough planning, I guess, to create a good question, but they might, though, on a calculator paper. You never know. And for the second one, which was minus 2, I'll try to find it. You get 12. That's a bit nicer. Minus 2, 12. And that makes sense, I think, because usually the one with a negative here has a positive here. The one with the positive here has a negative here, because cubic graphs are kind of like this. So minus 2, 12, 4 over 3, negative 6.52. Does make sense. But yeah. And now one more thing. You have to find maximum and minimum points. So what these are is that a stationary point can be either a maximum point or a minimum point. So a parabola, pretty easy, has only one maximum or minimum point, right? And if this is an x squared one, or like a positive x squared one, so positive 3, positive 2, anything, then it'll be happy face. It'll be like this, right? Which means the vertex point, or the one stationary point, will always be a minimum point, which means it's like the lowest one there. Opposite for a parabola with negative x squared, a negative a value, then this will always be a maximum point. Max. Min. Alright? With a cubic, usually one is maximum, one is minimum if it has two. And then you can get pretty crazy, and you have to find a way to see if these points, these stationary points you get, are maximum or minimum points. So for quadratic, it's really easy, because if you did the x squared plus 3x minus 5, and you got the 2x plus 3, and you got the stationary point to be whatever it was, I think minus 1.5 and minus 7.25. I had to go back and check, but yeah, you got that right. You know, because this is a positive x squared, this is by default going to be a minimum point. You don't have to do anything else. Now, for a cubic graph or anything higher, it gets a bit harder. I mean, for a cubic, you can still work it out, because if it's in the negative x value, it'll be a maximum point. If it's positive x value, blah blah blah. But that can be prone to mistakes, and you also have to know how this works with the negative x cubic and all that. So there's another way. There's two other ways. I'll teach you the one that I like, because I'm not going to teach you the other one. The other one is just you find actually I'll just tell you right now. You find the gradient of the point just before, you find the gradient of the point just after, and then you see if that's positive, then it becomes negative, then it's maximum point, and if it's negative, then it becomes positive, it's a minimum point. But yeah, that's a bit of trial and error. So then another way is you can use the second derivative. So if you use the second dy over dx, basically you just derive the derivative. So here you have the 2x plus 3. Then you derive this again. So then the x plus 3 cancels out, and then you get 1. So it just becomes 2. Basically it just becomes 2, right? Then you put in the x value for the stationary point. In this case, this is a constant, which basically means this is a positive 2, which means it doesn't matter what the stationary point is, it's always going to be a positive 2. And a positive 2 means that it's minimum. If it was a negative value, it would be a maximum. So I'll use this example. Actually, I'm not going to ask you any questions. Actually, I'm just going to use this example to show you a bit of a harder one. So this is the one we did before, actually, and we got these 2 points. But if we do the dy over dx with 3x squared plus 2, and then you do the second one, dy over dx, you get 4x, just 4x. Then you put in each one over here. So the first x value is 4 over 3. 4 times 4 over 3 is 16 over 3, which means that is a positive value, which means it's a minimum point, which means the 4 over 3, 6.52 minus 6.52 is a minimum point. And then 4 times the minus 2 gives you minus 8, which is a negative value, which means it's a maximum point. So the minus 2, minus 12, just positive 12 is the maximum point. So yeah, thanks for watching. This was actually a request from a commenter, which means I actually do listen to requests. So please comment anything you want. And good luck for the exam on Wednesday, the IGCSE non-calculator exam, if you're taking it. I am. Yeah. Like and subscribe, and you will automatically get an A star. Bye.